For this problem, we're going to find the composition of two functions, and then evaluate a composition at a given value. Here we're given f of x is equal to x plus 2 divided by x minus 2. And the second function, g of x, is equal to 2x plus 5. For these two functions, part A, we want to find the composition f of g and state its domain. In part B, we want to find g of f of negative 2, and in part C, f of g of negative 2. So we'll start with part A. The notation f of g is equal to f of g of x. So basically we just need to take this entire function g of x and we substitute it into our function f anywhere an x occurs. So we'll have 2x plus 5 plus 2, so we replaced x by 2x plus 5, over 2x plus 5 minus 2. We're going to simplify that. The numerator will have 2x plus 7, and our denominator will get 2x plus 3. Well, our composition, f of g, is equal to 2x plus 7 divided by 2x plus 3. We need to state the domain of this function. To find the domain of a composition, we first look at our inside function, which in this case is g of x. G of x is a linear function. It's defined for all real numbers, so we have no restricted values so far. The next thing we need to do is look at our composition itself. Look at any values which we need to exclude from this composition. If we look at this, we're going to divide by 2x plus 3, and we can't divide by 0, so we need to exclude any values which make this denominator equal to 0. If we set 2x plus 3 equal to 0 and solve that, we'll get that x is equal to negative 3 halves. And so the domain of our function will be all real numbers for x such that x is not equal to negative 3 halves. For part B, we want to evaluate g of f of negative 2. This is equivalent to finding g of f of negative 2. So we really need to first find the value of the function f when x is negative 2. If we come up to our function f and put in negative 2, negative 2 plus 2, that's 0. Negative 2 minus 2 is negative 4, and 0 over negative 4 is 0. So we need g of 0. So now we come to our function g, plug in the value 0. 2 times 0 plus 5 is equal to 5. So g of f of negative 2 is equal to 5. For part C, we want to find f of g of negative 2. This is the same as f of g of negative 2. So we first need to evaluate our function g when x is negative 2. Come up to our function g. 2 times negative 2 is negative 4, plus 5 gives us 1. So we really need to find f of 1. Put in 1 into our function f. 1 plus 2, that's 3. 1 minus 2 is negative 1. 3 over negative 1 is negative 3. So f of g of negative 2 is equal to negative 3. It's important to note that in these two cases we did not get the same result. So the g of f is not necessarily equal to f of g.